Hey all, today we're going to talk about two more types of 3D figures, and we're going to talk about the same ideas: lateral area, surface area, and volume. And so we have two types of prisms that we'll talk about. Let me get a highlighter here. We have rectangular prisms and we have triangular prisms. So these prisms have bases and they have heights. So in a rectangular prism, what you call the base is not necessarily as important as when you get to triangular prisms. So if you want to just call the bottom and the top the two bases on a rectangular prism, that works fine. And we have some dimensions associated with the bases. That's this lowercase p, that's the perimeter of the base. And this uppercase B is the area of the base. So in a rectangular prism, to get little p, you just add up all the sides. So in this one, we would have 5 plus 6 plus 5 plus 6. That would give us little p, the perimeter of the base. Big B is the area of the base, so we would multiply the length times the width. So in this example, we would do 5 times 6. H is the height. It's kind of like when we had a cylinder. The height is the distance between the two bases. So in this one, it's 7. The same applies to a triangular prism. The bases, though, this time are important, and they are the two triangles. So here my bases are kind of on the left and right side. These two triangles. And the perimeter of a triangle is sort of like the perimeter of a rectangle. You just add up all three sides. So you can see in this one we have one side is 4, one side is 3, and then using the information from over here, this long side is 5. The area of a triangle is different. It's 1/2 the base times the height of that triangle. So let me get a blank slate here. In a right triangle like we have here, the base and the height are always the two legs of the right triangle. So if I were calculating the area of the base, which is this triangle, I would do 3 times 4 times 1/2. The height of the triangular prism is still the same idea. It's the distance between the two bases, so in this case, 3. So these three formulas will be given to you, and you just have to know how to work with them and understand what the letters mean. So let's do an example. This is the one right from that example there. So we see that the base here is this rectangle, and so when we want to find the lateral area, we find the perimeter, which is 5 plus 6 plus 5 plus 6, and the height is 7, the distance between the two bases. So when we plug in, we get 154 centimeters squared. For the surface area, we're going to take this lateral area, this HP, which we already found is 154, and we're going to add to it twice the area of the base. So again, the area of the base, big B, is 5 times 6 here. Since it's a rectangle, we do 5 times 6. Multiply it by 2 to get 60, and add it to our lateral area, 154, which we found up here, to get the total surface area to be 214. And for the volume, we take big B, the area of the base, which was 5 times 6, and we multiply it by the height, which is 7, the distance between the two bases, to get 210. Let's do the triangle that we talked about at the beginning. To find the lateral area, we need the height and the perimeter of the base. The base is this triangle, so one side is 3, another side is 4, and then this side, which is the same in both bases, is 5, so we add those three together and multiply by the distance between those two bases, which also happens to be 3, to get 36 feet squared. The surface area, again, we're going to take the lateral area, that HP, which is 36, and add to it 2 times big B, which is the area of this triangular base. Since this triangle is a right triangle, we multiply 1/2 times the two legs 3 and 4, and that's what I have here. So once we do that, 2 times 1/2 times 3 times 4, we get 12, and we get a total of 48 feet squared for the surface area. And then for the volume, we're going to take the area of the base, that 1/2, 3 times 4, so we're using this again, and we're going to multiply it by the height, or the distance between these two triangles, which is this 3 feet, to get 18 feet cubed. So I want you to pause here and give this one a shot. So we got to find the perimeter of the base. The base is the triangle. There's one on top and one on the bottom now. And we have one side that's 3, one side that's 4, and again, this side is 5. So we add those together and we multiply by the height, which is the distance between those two triangles. We'll take that lateral area, put it in here for HP, because that's what that means. Multiply 2 times the area of the base. So again, we have a right triangle here as the base. So we multiply 1/2 times the two legs, 3 and 4, and then we double that to get 12, and a total of 72 feet squared for the surface area. And then lastly, to get the volume, we're going to take that big B, that area of the triangle, 1/2, 3 times 4, and multiply it by the distance between the two bases, which is 5, to get 30 feet cubed. So we'll focus on the triangular prisms in class, because those seem to be the ones that cause a little bit of trouble. We also are going to work with rectangular pyramids. They look similar to triangular prisms, but in this case we have one base that's a rectangle. We have a height that is just like in a cone, goes straight from the top of the pyramid perpendicular to the base. And then we're also going to have a slant height like we did with the cone that goes from the top of the pyramid down one of the sides. And again, the slant height is L. P is the perimeter of the base still. Capital B is the area of the base, so just like in a prism. So if we look at this pyramid, I have a square base that's 10 by 10, and I have a height of 9, and we're going to need to find L, the slant height, so we're going to use Pythagorean theorem, L being the hypotenuse, to get the slant height as 10.3, just like we did with cones. To get the lateral area, we need to find the perimeter. In this case, we add 10 plus 10 plus 10 plus 10. Multiply that by the slant height times 1/2. We're going to use that 1/2 LP, that lateral area. We can just plug that 206 right in here because we already did 1/2 times LP. And we'll add to it the area of the base. Since it's a square, we just do 10 times 10 and add those together to get 135.7. And last, to get the volume, we're going to take that area of the base, that 10 times 10, multiply by the height, that's that straight up and down perpendicular 9 inches, and then multiply it by 1/3, which is the same as dividing by 3 to get 450. Here we have this is the one from a couple pages ago. This time I have a rectangular base, not a square base, but I still need to find the slant height. So we use Pythagorean theorem again. Slant height is always going to be the hypotenuse. We'll get the perimeter of the lateral area by adding, not the lateral area, I'm sorry, the base, the perimeter of the base, by adding 2 plus 5 plus 2 plus 5. Slant height we found to be 5.1. Once we get that lateral area, we can plug it into the surface area formula right here where we see 1/2 LP and add the area of the base. To get the area of a rectangle, you just multiply length times width, or 2 times 5. Add those together. And lastly, we can take that area of the base, multiply by that straight up and down height, divide by 3 to get the volume as 25 inches cubed. So pause here and find these three values. So we gotta find the slant height first by using Pythagorean theorem. We can use that slant height. We can use the perimeter of the base, which is 11 plus 11 plus 11 plus 11, to get the lateral area. We're going to plug that lateral area, that 270.6 inches squared, in here for 1/2 LP, since we already calculated that portion of the surface area, and add the area of the base, which is just going to be 11 times 11, the area of that square on the bottom. Add those together to get the surface area, 391.6 inches squared. And lastly, we're going to take the area of that base, that 11 times 11, multiplied by the height, which also happens to be 11, divide by 3, or multiply by 1/3 to get the volume. So I want you to find the lateral area, surface area, and volume for both of these, this rectangular prism, square prism, and this square pyramid, and make sure you answer each of those, put them on the Google form, submit them to me, get your full credit.